I'm Richard. I'm another staff product engineer here at Intercom. I worked here for just over 5 years, so about half the age of Embercom. And for the past couple of years, I've been mostly involved in a project to build a new version of the inbox, which we've recently rolled out to all our customers. The inbox is one of the oldest parts of Intercom. It's evolved a lot over the past decade. It's where our customers talk to their customers, be it over the messenger, email, any other channel. Back in, I think it's 2014, when the first version using Ember was shipped, it looked a bit like this. It's part of the product that our customers spend a vast amount of time in. Many of our customers will spend their entire working day, working week in the inbox. So ease of use and performance are key attributes. And this, if you've used the inbox recently, this is what it would have looked like. Over time, it's grown a lot, both in functionality and complexity. Many of our customers are also dealing with much higher volume than they did in the past. And we wanted to vastly improve the experience of using the inbox. We wanted it to be faster and more efficient to use. We wanted a step change in performance. I had a mantra that every millisecond counts. We wanted a new, cleaner design with modern features like dark mode. We wanted to support internationalization, keyboard first interactions with modern patterns like Command K, action palettes, and alternative layouts like table view for conversations to be able to fit more context on the screen, and tons of other ideas we wanted to explore at the same time. We assessed whether this would be feasible to do incrementally, which is the usual thing we do at Intercom, start small, ship often, or whether the benefits of starting something new would outweigh the obvious risks of a rewrite. We decided to start fresh. It'd be a much shorter talk if we didn't. And the Inbox 2 project was born around 2 years ago. First of all, we created an entirely new routes at the top level inside the main Ember app. We didn't want to start completely from scratch with a whole separate Ember app. We'd lose all the benefits of the build tools and deployment tools. So we wanted to run inside the main big Ember app using the same libraries, still be able to share code across the app. But creating a new route at the very top level allowed us to experiment with reimagining every pixel, including the common Chrome, allowed us to control everything to do with booting up the app, loading the inbox. One of the issues we had with the old inbox was boot time, and that's one of the first things we tried to tackle. The approach we landed on to improve loading performance was to fetch just what you need when you need it. Inbox 1 and a lot of the other apps load a ton of data up front when the app loads, and then use that as a store of data. So lots of places in the app rely on that data already being present, looking up things by ID, but that massively slows down first boot, especially for larger workspaces who have a ton of data, like our own internal workspace. I don't know if you can see that, but there's an example of just booting up the Intercom's own workspace. There's nearly a megabyte of data in one of the responses, taking multiple seconds to fetch, and various other ones that take up quite a lot of time. And we're not alone in this. Quite a lot of our customers now have a vast number of teammates, tags, macros, tons of things that we currently just load up on boot of the app. Quite often our customers will open up conversations in separate browser tabs, follow links to conversations from Slack and open up new versions, rather than living in one instance all the time. So boot time performance, improving that has a meaningful impact on lots of people. Over the years, there's been caching layers implemented, complex multi-step boot processes to speed this up, but there's no design that just not fetching the data in the first place is a lot quicker. So in order to speed up boot time, we dramatically reduced the initial payload to the absolute bare minimum. So we've got some core details about the workspace, its name, some feature flags, and then some details about the current user who's logged in and their permissions, and that's basically it. Everything else we fetch on demand when we need it. We also introduced support for sparse field sets to many API endpoints. So by default, if you request something, all we send back is the ID, nothing else. You've got to opt in to retrieving the additional fields. So in the second example there, we're requesting the state and the assignee along with it, and that's what you get in addition. There's a ton of other properties you could opt into, but if you don't request it, you don't get it. On the back end, this also makes things a lot faster. We're not hitting the database, we're not serializing data that ends up getting thrown away on the front end. So we know we're only paying the price for data that's actually being used. And we've got the ability to specify fields deep down into nested structures as well if we want to. But generally we kind of stick to the top level and just request things from there. Yeah, we decided to go all in on TypeScript and skate to where the puck is going in the industry. We had some existing internal usage of TypeScript in Intercom, with some teams implementing new features in TypeScript, but the new inbox would be the first full product to be using 100% TypeScript all the time, everywhere. And around the time when the project was kicking off, the official TypeScript RSC was dropped. That kind of gave us the confidence that we were on the right path. The ecosystem was going with us, so this was a good bet to take. Our experience with TypeScript has been overwhelmingly positive. It's made our development experience so much nicer and given us a ton more confidence in the changes that we're shipping. The one downside is that we didn't have type checking in templates, which was the vast source of bugs. So components all nicely typed, things go through the template and it's a black hole. So component invocations might have misnamed actions, after refactor, required arguments forget to be passed in. A lot of these are caught by tests, but a lot of these end up being shipped to customers and bugs that could have easily been caught by TypeScript if we had end-to-end checking. A constant refrain in the team was, if only we had type checking in the template, this bug wouldn't have happened. And then Glint comes along. Glint brings type checking to the templates, exactly what we've been asking for. We were keeping an eye on it through the whole project. We were aware of its existence. We just wasn't mature enough to use most of the time. And then at the end of last year, when Glint was readying a 1.0, we jumped on board and got it working. This was a multi-step process in adopting it in a code base as large as our one. We didn't want just the new inbox to get the benefit, but to be able to roll this out across the whole of Intercom. So first of all, we scripted adding backing files for all template-only components that previously had no JavaScript or TypeScript files. We need these as you need somewhere to define the types for the component. You can't just do that in the template on its own. There's a template-only component import you can use to define the signature and arguments for a template-only component. This still doesn't create a backing class. It's just for typing, so there's no performance cost. You're still good. You're still using just a template-only component. And then the bottom half of this is some boilerplate that's needed for every component to wire it up to the registry. And this is because Ember's template resolution occurs dynamically at runtime, and Glint needs a way of mapping the names of what you use in your templates to the actual backing value that they'll be resolved to. The registry does this and makes Glint aware of the class name and also the string form that's used in the component helpers. In the future, hopefully not too distant future, this won't be needed once we've got the statically defined template system, but at the moment, there's just a little bit of boilerplate you need to add everywhere and kind of script away. Then we added a script to update all the other existing components to also add those to the registry and change the component types to use the new signature type. So instead of just passing in the arguments, you also define what named blocks there are, what element, if any, the component has. And the elements there, so if you have a component that has no element, Glint will complain if you try and give it a class, so you give it other data attributes. Otherwise, they end up being dropped. So it kind of enforces that you've got to put your splat attributes on there somewhere, or you're opting out of that. Finally, there's a command that ships with Glint called auto glint no check that adds this comment to the top of any template in the system that doesn't currently pass type checking. So once that had excluded all the files that weren't valid, we now had a green build. Any new files were opted into type checking by default. Any existing ones could be incrementally worked on. And we've currently got, I think it's 60 to 70% of components in Inbox 2 are all fully Glint type checked. And we're working towards 100% fairly soon. We sometimes wanted to be able to use existing components inside of Inbox 2 from Inbox 1, either as a stopgap to re-implementing them, or as they were too complex to re-implement in the time we had available in the project. We also occasionally wanted to take new components that we'd written for Inbox 2 and use them elsewhere so that we could test them with customers who weren't opted into the Inbox 2 betas. And this was tricky for a few reasons. In Inbox 1, there's a central service called the app service, a God service, populated on boot with all the app data. And in Inbox 2, we boot completely differently. We don't have an app service, but almost every single component in Inbox 1 and elsewhere pretty much relies on the app service in one way, shape, or form, or many other services that similarly rely on that. And those components just wouldn't work inside of Inbox 2 without a ton of refactoring. So yeah, in the example at the top, we can see the Inbox 1 way of doing things, grabbing the app service, looking at feature flags off the app service. And Inbox 2, there is no app service. We have a different service called the session, and we look up feature flags based on that, and a ton of other differences, neither of which kind of compatible with each other. So what we ended up implementing were adapter components. So these wrapped the legacy components and set up the world in the background the first time that the adapter was put on the page. And then that yields once it's fetched the data in the background. So the Inbox 1 component inside can live there happily, not knowing anything about the difference to where it exists. We did the same to allow Inbox 2 components to live elsewhere, which allowed us to validate a bunch of experiments inside the old inbox. This will be a controversial slide. Probably the most controversial decision of the project. We decided not to use Ember data. Sorry, Chris. When the project was kicked off, we were on Ember data 3.12, 3.12, which was even then more than 2 years old. And we had kind of no upgrades on the horizon. Even now, today, we're stuck on 3.20. Team Front-End Tech doing a load of work at the moment to try and unblock us. But it's been a long journey. I think we're stuck behind Ember data model fragments, Ember data factory guy, and a bunch of other things that's just making it super tricky to get to the new versions. And that meant we weren't able to take advantage of a ton of the great work that's been done to kind of slim down Ember data, break it up, or look at any of the approaches that I think LinkedIn have used with M3, the alternative model layer, to make things faster. We benchmarked Ember data versus just plain old fetch requests, turning them into JavaScript objects. And there's just a massive gulf between them. We fetch and display a vast amount of objects when rendering conversations, especially long ones. And the overhead was just super noticeable when loading and switching conversations. And a lot of the time that was spent in Ember data. Caveat here is a lot of this is to do with our Ember data setup, the version we're on, the heaviness of our adapters and serializers, but it was enough to tip the scales towards experimenting with something a bit more lightweight. We'd also experienced issues in the inbox with long-running sessions causing the browser to run out of memory. So many customers, as I said before, live in the inbox with it open for hours, days, weeks at a time in some cases between reloads. And that can result in the identity map just filling up with old conversations and old conversation data, which gets very memory hungry. We often had customers complain that their browsers basically crashed because they run out of memory. We'd implemented a number of approaches over the years to get around this. The most recent, which I think was my first project when I joined Intercom, was a reference counting garbage collector that would basically monitor the conversations that were in use, notice when they weren't used for a while, unload those from the store, along with any associated models and comments and things like that. But we didn't really want to bring that approach over to Inbox 2 because it was verbose and error prone. What we ended up with was pretty simple, plain TypeScript objects. We have a wire format that describes the JSON format that we receive, and a deserialized method that transforms that format into the object itself. Objects then can be updated. Also had a serialized message that then turns that back into the wire format that we can send over the wire. Dead simple, but extremely manual. Making any change, adding a new property, changing a type requires a whole bunch of boilerplate and lines of code needing changing. Fetching and deserializing the data was also done by hand, calling a simple wrapper around fetch and converting the JSON into objects by passing them into the deserialize function. We don't currently do any verification that the JSON that we receive actually matches the wire format, which has caused some issues. And we just kind of rely on trust that the types we defined match what we get from the server. We've been investigating some of the libraries that let you validate that at runtime, but at the moment it's a bit of trust. And normally the person that's changing the back end is changing the front end too. So this custom approach ended up being fast, but it certainly came with a cost. And it's not an approach I'd recommend to everyone or anyone, especially if you're able to use the more modern, latest versions of Ember data. Not having an identity map solved our memory issues, but the cost of that was extraordinary out of work to coordinate changes and keep multiple representations of the same object in sync with each other. Because quite often you'll have a conversation on the page and maybe the same conversation in a sidebar or over on a summary view. You make a change to one and they're all different objects. So how do you actually update all those? Whereas with an identity map, they're all the same thing, super simple. There's also an assumption that the majority of data was read-only, so we didn't need to take advantage of a bunch of the dirty checking that Ember data brings. That hasn't turned out to be quite accurate, and that slowed us down on occasion too. And then there's just the cost in differences between parts of the product. People get used to the way their part of the product works, and they come over to Inbox 2 and it's all different. So it takes time for new engineers to get up to speed on how we do things versus the rest of the product. I'm not sure we'd make the same decision today. We may find our way back to Ember data in the future. Time will tell. No decisions set in stone. We will see. So after all that, what did we build? So performance is one of the main things we're after. So this is an example of Inbox 1 navigating around. I'll take a drink while this goes. Lots of spinners. Scrolling takes forever. Every time you change a conversation, it's a bit much. Still going. There we are. Click. More spinners. Get the idea. It's a bit slow, a bit frustrating if you're spending your day in here and every single conversation that comes in just takes that bit of extra time that you really don't think it should. And here's what we shipped with Inbox 2. Same kind of thing, navigating around the inbox, clicking, stuff is just there, kind of works, I should hope, as you expect. There's a ton of requests going off as you hover over things, so kind of predicting where people are going to click and loading the data in advance, just so there's those extra few milliseconds we save as well. And a lot of it was due to slimming down the requests, slimming down the way we fetch data. A ton of back-end work as well as the front-end work. One of the efficiency improvements we added was Command K, so a keyboard-first way of interacting with the inbox via a command palette. That's kind of a common feature of some modern productivity apps. So this is what it looks like. So when you hit Command K at any time in the inbox, we bring up this action palette with actions based on the current context, so where you are in the app. So here we are in a conversation. So the actions you get are conversation related of compose a reply, compose a note, insert a macro, these kind of things. These also show the keyboard shortcuts you can use to invoke them directly. It kind of eases people into using shortcuts without having to constantly refer to help docs. So you can start off using Command K, find out how you want to do it, and then next time you can just hit N and you're in compose note without having to go through. You can type to filter the available actions. So here we've typed assign and it's focused the assign to action at the top, but it's also brought up some related actions. So use a macro that contains assign in the title, or go to the unassigned inbox. Scrolling through selecting a top level action brings you to a second level where you can kind of scroll through and filter the options. So here we're on the assign to pane, and you can filter through all the people you can assign to. We also support completely custom pane components. So here's the snooze action that brings a calendar and a list of times along with, instead of just a normal plain old list. So this is all coordinated through a central service which has a list of all the actions available in the app. These can be simple actions, where essentially just a button with an icon and a shortcut, or they can be more complex actions which show like their sublists or have custom components. For example, I think this is the switch language action, which has, again, an icon, has a custom pane component, so it overrides what happens when you click on it, and then shows how to fetch the data. These can be pretty simple like this one, or can grow to be fairly complex. And by default, we don't show anything in Command K until it's in a context that makes sense to you. So we do that by registering an action through the template. That lets you use all the data that's available in the context that you're in to decide whether this action makes sense or not, and what happens when you actually select that action. So here we're saying the open command, which is planned to reopen the conversation, only makes sense when the conversation is currently closed. And when that is triggered, we call the open conversation action. And again, these can get as complex as you like. That in itself is implemented in a simple TypeScript only component, which doesn't have a template. And when the component is rendered, we tell the Command K service that the action should be active. When the component's destroyed, we tell it it's no longer active. There's a bunch of complexity under the hood here in handling kind of race conditions, as it's not guaranteed that will destroy gets called at the right time when you'd expect. And we also handle giving these actions a priority, because it could be the case you've got two actions with the same ID on the same page for different things, and you need to control which one gets performed when you perform a shortcut or select the action from Command K. So an example there is you could have a conversation up in the main center of the window and another conversation currently active in a slide over, and Command K open or reopen wants to affect the right one. We do that in a similar way to, I think, the Ember keyboard library, by just passing in a priority as an integer. So higher priority items take priority first. Yeah. Another benefit to kind of re-implementing everything was the opportunity to build in kind of wide sweeping changes that really required every single thing to be updated, or it just looks weird. So things like dark mode and internationalization, like Aaron mentioned earlier, they only kind of make sense if everything is in dark mode when you switch over, and not just half of the app. So we have it so that you can go Command K, switch to dark theme, and you're over into a nice dark mode to stop burning your eyes. That was all implemented with Tailwind. Everything is in Tailwind in Inbox 2 and quite a lot of the rest of the app. There's some custom color palette stuff in there, so like the DM gray and things like that are custom colors. But aside from that, it's just standard Tailwind. And it just works. It's been great. Okay, so that's what we built. How did we actually go about testing it and shipping it? So as this was behind a separate route, it was fairly easy to gate access to the early versions by just adding a feature flag to that route and saying if you're in the feature, you can access it. If you're not, you can't. And from relatively early on, we had some kind of keen customers opted into that feature flag that wanted to test out the new designs as we were working on them. They could continue to use Inbox 1 side by side, playing around with the work in progress Inbox 2 in a separate window, a separate tab. Later on, we enrolled some workspaces into a beta that let teammates switch between versions. So we did that with a go to new inbox link inside of Inbox 1. And if you click that, you're bumped over to Inbox 2 stickily. So anytime you opened up the app, you are still in Inbox 2. Any URLs you follow, you're in Inbox 2. But at any point, if you're running into issues or bugs, not that there were many, or missing functionality, you could click the revert to old inbox as an escape hatch to get back to Inbox 1. About a year ago, we launched officially. So all new workspaces created after that date were Inbox 2 only. They don't see the option to go back to Inbox 1. But all existing workspaces got the opt-in. So if you're using it before then, you can try it out, but switch back again. We also rolled out the ability for some workspace owners to manage that process so that they controlled switching their whole workspace over or not. So they didn't have teammates on different versions. Then gradually over a number of months or nearly a year, as we fixed issues and filled the gaps, we started to migrate batches of workspaces over. So they'd be switched to inbox 2 with no opt-out. And then, yeah, so a few thousand at a time until eventually, about a month ago, we globally enabled this to everyone. Everyone is on inbox 2. Inbox 1 doesn't exist anymore. So we can start to delete all the old code. Hopefully the number of routes will go down. A whole bunch of legacy code and old Ember objects will disappear. So that will be some very nice PRs coming. So I've got questions.
Simple enough question. You started off with the demo of the router and you were like, oh, it's a completely different top level route.
Mm-hmm.
I assume it eventually made its way into the real
That'd be nice.
It hasn't?
No, it's still there. If you go and use the inbox today, you'll notice it starts at intercom.com/inbox. And if you go to any other products, it'll go intercom.com/app. Oh, yeah. But yeah, so it's still a completely separate thing. May get moved over time, we'll see. But yeah, at the moment, it's still completely an island of its own.
Quick question on TypeScript. So as most people who've used TypeScript will know the benefits of it, but with like large legacy products that you might have a large code base for, how did you split the developer burn for that? And also, how hard was it to pull your code base from JavaScript to TypeScript then?
We had the advantage that we had no existing JavaScript to convert to TypeScript. So this is one of the advantages of kind of starting from a fresh part of the code base, that we could kind of blaze the path and just write in TypeScript from the start. There was a ton of work in kind of converting existing components over to TypeScript as we went, but they were all rewrites as opposed to kind of transpiling them or anything like that, because they all had to, there were a ton of other patterns we were changing at the same time, essentially. So it was more a rewrite than having to convert, line for line. And a bunch of the things we've kind of learned from this is what good TypeScript looked like, and now kind of examples for other teams, because we've gone through the process of writing very bad TypeScript, figuring out what doesn't work, and now we've got some decent examples, hopefully. We'll change as we go.
There's one question in the Zoom. You had that migration period, right, where you had some users still on inbox 1, some on inbox 2 already. And the question is whether during that period you had to implement features twice, like once in the old and once in the new.
Yeah, so we had, when we kind of kicked off the project, that any projects were kind of underway, they would carry on developing those on the existing inbox, but everyone else was kind of aware of what was coming. And we tried to get to the point where teams could start to build functionality on inbox 2 fairly quickly. But there was a period of time where people were building things in the knowledge that they were going to have to do some work again, basically. And some of that was a case of build your stuff with the learnings and kind of designs of inbox 2 so that you could quite easily just use those components in the other place and things like that. But yeah, there was a period of repeated work, I think, but not a huge one, because we got to that point relatively quickly. But yeah, and we had some big other initiatives going on at the same time, which were sizable, that could also kind of project a launch date after inbox 2 was coming out, so they could be building on top of inbox 2 without fear of us slowing them down. Yeah, so some kind of planets aligning and things, but yeah.
Quick question, since you mentioned that you were not using Ember data, I was curious about the storage layer. Like, are you still using, I guess, like services to like do we have like a custom storage layer there that you've implemented?
And what do you mean by storage?
As in, like, when you have Ember data, you can like still like use it, the local cache, and like use the local.
Oh yeah. So yeah, Ember data has the store.
Yeah, like the store. I mean, like, did you have to implement like a custom solution?
Yeah, no. So basically, all the data in inbox 2 is essentially transient. You fetch it, you throw it away.
Okay.
You want it again, you fetch it again.
JavaScript objects, that TypeScript object.
Yeah, exactly. And kind of sideloading a lot of things. So instead of fetching something that had a bunch of ID references for things that you then go and look up, we send those objects down. So it's like, I think in one of the examples, you had like the assignee, and that was a kind of fully hydrated admin there, as opposed to being the ID of an object that you go and fetch from the store. We send that data on every request, essentially, and sideload it as you need it, basically. Yeah.
You talked about your components there. with Glint, and you said there was like 60% of them already converted over or something. Maybe it's still a stupid question, but yeah, you can do that, right? You can run like your component library, like half on Glint and half regular, and migrate them.
Yeah,
progressively
essentially all
over.
Glint's giving you is the type checking. So if you're opting out of that, you're just opting out of safety, basically, or kind of acknowledging that there's stuff in there that is broken that you can need to come back and fix. So yeah, we've just got 40% of the code that just isn't passing yet, maybe because we don't have types for some of the helpers that we use in there, or we don't have types for some of the other core components. So we kind of run a process where you kind of look for the things that most things are referencing, and then fix the types on that thing, and then hopefully a bunch of other files will pass. It's just kind of iterative process to try and find all the things that other things are referencing and kind of fix the low-hanging fruit first. And now we're at the point where the remaining 40% are kind of more complex components that legitimately don't pass type checking, but we just need to go through one by one and fix all the types, or add the types to the component signatures and things like that. So it's just a bit of a manual, laborious process to go through that we're kind of Boy Scout principling our way through. It's like if you touch a file and it's got the no check on the top of it, your job is to get rid of that by the time you make your change.
What was the uptake in customers using that? Because it's an interesting feature to have on a browser-based application to incorporate the keyboard.
Yep.
Do you have any metrics, like Pendo metrics, that were coming in there for customers, and was it used a lot?
We've got a ton of metrics. I can't remember anything offhand. It was used a lot by some categories of people and not by others. So people who were kind of heavily keyboard heavy users in Inbox One, they use the shortcuts, their uptake was dramatic, and we can show that their efficiency improved. So their like time to respond to conversations, time to close, kind of dramatically improved. And for customers who are kind of mouse centric, they continue to be mouse centric, and there's not much you can do to push them towards a keyboard first world. And then you've got a group in the middle who knew keyboard shortcuts didn't exist, didn't use them very often, but now are kind of gradually improving over time. But yeah, we've got metrics that show it was very beneficial to some, less to others, but such is life. Yeah.
Cool. Actually, just a segue on that. Did you find that the accessibility was good for it as well, considering that most accessible users would probably be very keyboard based as well?
I think we've got a bit of a kind of self-selecting setting that the customers we've got are used to. If they can or cannot use the inbox, they can use what we had there in Inbox One. I don't know what the uptick is from like new customers coming in or anything like that, but it's a more accessible inbox than we had before. It's still not fully accessible. There's more work we'd like to do, but it's better than it was. Yeah.